Hi, everybody. Welcome to the last talk of the day. I'm Sam.
And I'm Kiana.
We're going to teach you about integrating back-end systems with Firebase to make your app better.
So I hope you had a really good day of talks today, and you've learned about how to use Firebase to build and grow your apps. And I'm sure by now everyone has some great ideas on what you want to do next. But as you get started on your brand new app, you might start running into a little roadblock called legacy systems. And like all legacy code, it's not usually written in a language of your choosing. And you can't just rewrite it willy-nilly to write it on Firebase instead. Or maybe you need to integrate with some existing tools and services, or even extra databases or machine learning algorithms. The apps we need to build are quite complex, and they don't exist in isolation. They usually have to deal with our pre-existing infrastructure, external data, and other constraints. But luckily, Firebase provides a set of admin SDKs that make it really easy to build custom solutions on top of Firebase.
So, Kiana's going to log me into her laptop. My bad. And then we're going to use our Fireflix app as an example today. So Fireflix is a movie rating app. You can use it to rate movies and find other movies that may interest you. But we have some back-end functionality in the app that we want to restrict to only trusted users, things that not every single user who uses the app should be able to do. So let's jump in. You can see here that we have the Fireflix app. There's a home screen of movies. I can add them to my library. I can add a review. And I can log in, either with Google or with a code. And we'll explain more about that soon. So Kiana's going to show us how to add some trusted functionality to this app.
So if we could switch back to the slides. So the first thing we need to change is to give Fireflix some user roles. But why do we need them? What's the difference between a user and a moderator and how they use our app? Well, in our case, we need a set of moderators that are able to manage trusted content. See, with normal users, they can see their own data, but we really don't want them to be able to see other users, and especially we don't want them to edit it. Moderators, on the other hand, they're vetted by our admins, and we can give them access to our trusted data and services. Luckily, Firebase Authentication gives you a really great mechanism to create these custom roles called custom claims. So we set a property on our existing users using the admin SDK, and we can also include them as part of the token when we use custom authentication. Then, once we have our custom claims set up, we can use security rules to restrict their access from the databases, or we can restrict what pages are shown on the front end, or even verify the access using that token from the back end. And our admins need to be able to create this list of moderators ahead of launch time. They don't want them to have to sign up as the app is being launched, and then later add those roles. So we want to invite them directly via email. So what we have to do is create a user using the admin SDK, add custom claims, and then create an invitation code and email it to them using our custom user invitation system. So let's see how we build it. First, our admin is going to create those user accounts and add the roles we want to them. In this case, a moderator role. Then we'll store the invitation along with that new user's UID in our custom server. Then send that invitation code we generated over to the user we want to invite. The user then can talk to the custom auth server that we just created and send it back the custom token. And they'll receive an auth token in response, which you can then use to log into Firebase. Now, some of you may be thinking, why don't we use Firebase's built-in emails, like reset password or email link, to do this instead? What's the point of building a whole system? Well, while it seems simpler, it's just not a good strategy, because you end up giving your users a really bad onboarding experience. It doesn't look pretty. No one really wants to see an email password reset as their way to join your app. Plus, the links usually expire within a day. So let's talk a little bit more about how we do this token exchange. So first of all, the user sends those credentials over to the auth server and receives back that custom token I was talking about. But the interesting part comes in when we pass that token to Firebase Auth. Now, we start with that custom token, but Firebase Auth actually verifies the token's signature that we signed using the admin SDK. And then it returns an ID and refresh token, which is the same as you would do with Google Auth or email password or anything else. Then the user can authenticate to Firebase's services using that ID token and get back data. And this is what the custom auth token looks like. It's generated using the Admin SDK, and it's signed using it as well, so Firebase can verify that signature is correct. Then we also want to include custom claims in it, so we can automatically add those to the user's token. Then when you exchange your token with Firebase, it passes you something that looks like this. It's signed using Firebase's signature instead of the Admin SDKs, so anyone, including your backend services, can verify it's real. And again, it includes that custom claim we set up. And here's some code in Python in this case, because that's what we decided to use to set up our invitation system. And it uses the Admin SDK to create an auth user with custom claims already attached. Then we create an invitation using a random code and email it to the user and also save it in our database. Then our backend system is running Go. And this is what the website will use to verify that the user is signed up correctly. So we'll check the custom claims in that token, and we'll return back to them a new auth token, that custom auth token I was talking about, with those claims involved. And we'll just demo that real quick. So I have my Python script here. I'll create my new user. And hey, this is what the email would have looked like if I was going to open my email. And then in Firebase Auth, I can see here that my new user was created. And you'll note that it has no providers, because the custom provider does not show up here.
OK. So now that we have our custom authentication server set up on the back end, we need to wire up the front end to log in users with their invitation codes, the ones that are sent in the email. In our case, we're using Cloud Firestore as the database for all user information. But this will work for any user store you have. So if you have LDAP or Active Directory, or you just have a SQL database somewhere with all your users in it, this technique will apply for your app as well. If you remember the flow, the server sends the email and the code, sends the user an email containing a one-time use code for sign-in. When the user clicks on the email and gets the code, we need to send that code back to our server, which will at that point generate a custom auth token. Then this custom auth token can be used on the front end to sign in with Firebase authentication, and that'll start a session. The custom token is signed by the server and contains the claims that I am a moderator. So that'll be reflected in my Firebase authentication session. Let's take a look at this code here. So you can see I send a post request to my server with the email and the code. This comes from a form in the front end. The server returns to me a token. I then take this token and give it to Firebase Auth. This token is that custom token that Firebase authentication can understand. It'll sign me in and return me a Firebase user object, which will reflect that I'm a moderator for this session. So now that I'm a moderator, I should be able to access the Moderators tab in the application and perform some admin actions. So let's try that. You can see here, I'm back in the Fireflix app, and I'll quickly log in as a regular user, in this case with Google Auth. Up here is where the moderator tab would be, but it's not here at all. This is the Google account I just logged in with. But I'll log back out. Now here's the email that Kiana's script sent me just a few minutes ago. So it invited me to be a moderator and gave me this fancy random code. I will sign in with that code instead. This is the form that's going to send back to our server. And I will mess up big time. I'm going to do that again. Well, last talk of the day. It has to be fun. Now, yes, I do. I'm going to do that one more time. And now I'm logged in as an admin, like I promised. And you can see that we have a moderator, not an admin. And we have a new moderator panel I can access, which will be explained more as Kiana presents.
So back to the slides. So now that we have moderators, we want to have our server verify their ID tokens so we can do some things in that moderators tab. Then we can restrict those sensitive services just to those users that have the moderators claim. And one of the things in this case that we want our moderators to do is manage our social media. We can't do this client side because those SDK tokens and API tokens are actually secrets. And we can't have anyone just scrape those and start spam posting. So this could be any restricted operation, but for now, we're going to use tweeting. And our server is currently running the API, but let's see how we can restrict it to trusted users. So our authentication user will send their ID token plus the requested tweet over to the backend server, and then we'll send it on to social media. And the way we'll do this is with that Firebase token that we just sent to the server, we're going to verify the signature using the Admin SDK. And then we'll actually extract the claims from that token as well. So this is what the code would look like in Go. So we'll send our unauthorized request from curl to demo the failure case in a second. And so we'll verify our ID token here, and then we will check if the claim is a moderator or not. And let's demo it. So I have my, okay. So I'm going to send a tweet about Sparky. And then it sent the tweet. And I can check over here in Twitter. Hey, it's there now. But if I log out, since I can't get to the moderators tab, it'll actually fail. See? Nothing happened.
Yeah, let's clap for nothing. That was some good nothing. All right, let's head back to the slides here. OK, so we locked down privilege actions. Nothing happened on the back end. And now they can only be done by moderators. But there are still a number of things that you can do in the front end of the app that are harmful or malicious that you don't need to be a moderator to do. We want to build some sort of detection layer over the events that happen in our app to respond in real time and take action on the back end when we detect these critical events. Remember that our clients, once they're signed in, talk directly to the database. That's one of the best things about using Firebase to store your data. But security rules analyze each request as it comes in individually. We don't have any opportunity to analyze the request pattern. Each individual review, in this case of a user posting reviews, might be valid. But if they post too many reviews at once, that would be considered spam. It's a spammy pattern made up of individually valid requests. So security rules can't really save us from this type of pattern. We're going to use Cloud Functions to build this detection layer over the events in our app. Cloud Functions are event-driven, and they're scalable, which is exactly what we want here. We want to respond to events as they come in. So as these reviews come into the database, our function will be triggered, and we'll be able to track usage and sort out spammy patterns there. This is a much simpler and more responsive strategy than using like a cron job or having an intermediate server that runs before every request. The Cloud Functions will run exactly when we need them to. So here's a Cloud Function that we've set up to fire every time someone posts a review. You can see here that the trigger is set on a Firestore document in the user ratings sub-collection. That's users for any user wildcard, ratings for any rating. And the onCreate event type means that this will fire when a new document is created. Now let's jump in to the body of this function, where we'll decide if it's part of a spammy pattern or not. So here's the body of the detect invalid activity function, which was inside the previous step. For every request, we're going to update the user's activity log, which is just a list of how often they've posted a review in this case. Then we'll check the activity log to see how it looks after this post and see if the user has posted too many reviews lately. We do this in a transaction so that even if the user is spamming really hard and running tons of requests, we know that we're going to get a consistent result. We can't be fooled by a race condition. It's important to understand that a Cloud Function is a trusted environment in this case. If we did this transaction on the client side, it would be consistent as well. But a user might go further and try to hijack our application itself. Remember that you can't trust data that comes from the client. Think about how easy it would be to open up Chrome DevTools in this app and just delete this piece of code from the JavaScript. So we want to run this in a trusted environment. OK, so we can detect a spammy user with a cloud function. What are we going to do once we found them? The first thing we're going to do is disable the user's account. There's a key distinction here between disabling and deleting. If you delete a user's account, it's very easy for them to just sign back up with the same email. The Firebase authentication will say, yeah, that's a new user, but we want to keep this person out. So if you disable account, that means that the email's kind of locked down and they can't log in anymore. Also, their refresh tokens are revoked. So in 1 hour, when their ID token is expired, they won't be able to get a new one. OK, I hope at least one person caught that and is like, 1 hour is way too long. I mean, if they're spamming your application, you can't just wait an hour for them to get locked out. So you're right, we're going to stop the spam immediately with another technique. In addition to disabling the user's account, when we detect a user that we want to disable, we'll add them to a blacklist. We'll just keep a list of user IDs that are blacklisted. Then we can consult this blacklist from security rules on each write, which will block the next request, the first one that is past our rate limit. So in the cloud function I showed you before, we'll have just added the user's ID to a list in the detect invalid function. Then we have these security rules, which will help us check the blacklist. So these will come in before each write. So if a user exists in the blacklist, we're going to deny their writes. You can see here that we have a function called isBlacklisted. And that just checks for the existence of a document in the blacklist with the user's ID. We also say that for the blacklist, we're not allowing any writes from the client at all. So there's no way that a client-side write, even if they mess with your code, could modify the blacklist. And then when you're writing the ratings, we'll check the blacklist before we check anything else, before we validate the data or look at anything else. Blacklisted users have no ability to write ratings at all. So let's go back into the app, spam it up, and see if all this works. It'll go better than the last demo. I guarantee it. OK. So here I am back in the app. I'm going to go to My Movies. I don't have any movies. I'm going to get a new movie. All right. I'm going to add a review to this movie. And then I'm going to do that too many times. You can see that I'm clearly spamming. I'm just adding reviews. And that one's submitted as well. Add another review. I'm going to change the rating. At this point, it's pretty clear that I'm a spammy user. And finally, after the third one, because our rate limit that we set was 3 in 10 minutes, I got an error submitting reviews. This error came from security rules, so there's nothing I could do with the dev tools here to get around that.
Way better than an hour. So the last thing we want to do, though, is integrate via REST to a dashboard that we created. Now, this dashboard was already written for us, but it was written in Ruby. And we don't have a Ruby Admin SDK right now, unfortunately. But what we do have is a REST API. And using the REST API, we can talk to Firebase with whatever language we want. So we'll monitor how often people are posting and see how often people are hitting that spam limit. So with our dashboard tool, what it's going to do is use that same function that listens to the Firestore, and it'll post how many reviews you've made over in real-time database. And then we'll use Ruby to query for the most recent active users. And then we'll display it to some of our admins. Now, since Ruby doesn't have that admin SDK, we have to fall back to other methods of authenticating. In this case, we do have a Google Auth library, but even if we didn't, we could actually program an OAuth flow manually. We don't usually like to do that, so we'll stick with the library for now, though. Then we'll query the list of the most active users periodically. This is what our Ruby code looks like. So first, it's going to use that Google Auth library and set the scope cloud platform, just so we can get the access to the real-time database via the admin. Then it'll create a URI, which is our REST API one. And then finally, we'll add those Google Auth headers to the crest before we make it. And let me show you how that works. So If I go over here, I'm going to run my Ruby client. And I can see Sam just added 3 reviews. But let me log out and log in as a new user. And then I'll add a new review. And in a second here, should pop up. Yep, and we just had our moderator post a review.
Great. OK, so we have REST APIs for basically all of our products. So you can access them from any device or software stack that you may have. I mean, you just saw us using a Ruby script, but if you have like an Internet of Things toaster that runs like a made-up language, we can probably get Firebase working on there as well. We've covered a lot of things today in a fairly small application. We have authentication, talking to the app, talking to Firestore. That's where we started. We had an invitation sending server. That talks to authentication as well as Firestore. We added a custom auth service to mint tokens, which has to talk to the app as well as to Firestore. And then we added a service that performs authorized actions from moderators. In this case, it was talking to Twitter. That also has to communicate with the front end of the app. We have functions, which are talking to Firestore. The functions are disabling the users and authentication. And then we have security rules in the middle. And then we have the real-time database, which is where that leaderboard script ran. More than any specific detail in this diagram, it's pretty clear that real-world apps get complicated. They're very messy. And when your Firebase app gets complicated, we hope that you'll reach for the Admin SDKs. All of the Admin SDKs are developed open source on GitHub. We'd love to hear from you, bug reports, feature requests. You can send us pull requests. We're very happy to accept contributions. We're also working on adding support for more languages, so .NET and even Ruby, which we mentioned we currently don't support, but we're working on. If you know those languages and want to help us get it right, find us on GitHub, and we'll be very happy to work with you. You can see the K1 short link will take you there. For next steps, hit up the short link and help us shape the future of the Admin SDKs. Thank you.